Okay, in this video I'm going to be going through problem number 2 in the first momentum review. Okay, I'd make sure you have a copy of the problem in front of you while you're looking at this solution. So the problem is as follows. We have the dynamic duo Claude and Maud are performing in the final round of I can't pronounce this, some skating competition. So it's saying Maud begins by skating into Claude, who is standing still. After the collision, they move off together with 960 Newton seconds to the right. And we're going to assume that Maud has a mass of 55 kilograms, Claude has a mass of 65 kilograms. So the first one is saying, what is the skater's final velocity? So to solve that, you might want to draw a quick picture. So there's Maud skating initially, runs into Claude, who's standing still, and then what happens is they run into each other. We could kind of say stuck together, and then they're moving together after that. So it's asking what is their final velocity. So their final, well, we know one thing. We know their final total momentum is 960 Newton seconds because it told us after the collision they're moving with 900 Newton seconds of momentum to the right. So we're going to say the total net momentum is 960 Newton seconds. And this is really equivalent. Remember that momentum is mass times velocity. So because they're one object, this 900 Newton seconds is really equivalent to the masses of both of them together times their total velocity. So we're just going to add their masses together. We're going to do this. So we're going to say the 900 Newton seconds is equal to the first mass plus the second mass, so both of them together, times their final velocity. And it's one final velocity because they're stuck together. And we're going to plug in for this, so we're going to say still 960 Newton seconds, and then we add up each one of their masses. We got 55, we got 65, times the final velocity, plus. And if we solve that, we're going to get the final velocity. We're going to get a final velocity of 8 meters a second. And it's going to be implied that that's to the right because their total momentum, it said, their total final momentum was to the right. Their final velocity is going to be to the right as well. So together they're moving off with 8 meters per second, a velocity of 8 meters per second to the right. So that is part A. The next one is what is their total final momentum? So I'm going to solve that on a clean sheet. So their total final momentum is really, again, it really says it in the problem. It says, okay, after the collision they move off with 960 Newton seconds. That's really it. There's not really too much work. And the explanation is, it is the momentum of both of the skaters, after the collision. So again, it really tells us in the problem with the final momentum is there's really not much calculation that we have to do here. Minimize that. So that's B. C is saying, okay, well, that's their final momentum. What is their total initial momentum? So C, their total final momentum, we just figured that out, is 960. So to figure out their total initial momentum, it's really going to be equal. And the reasoning for that is the total initial momentum is equal to the total final momentum. And the final momentum is 960, so the initial momentum is really 960 Newton seconds as well. And the reason for this is the conservation of momentum, which basically says whatever you have here initially is going to be the same over here. That's what you have finally. It's basically saying that the momentum's not going anywhere. It may be distributed differently among the skaters, but it's never created or destroyed. It's just moved between skaters. So that's C. The next one is calculate Maud's initial velocity. So we're calculating not Claude, but Maud's initial velocity before they kind of stuck together. So his initial velocity, like at this point in time. So his initial velocity, to figure that out, we're going to look at the conservation of momentum in this situation. And for notation purposes, I'm going to say number 1 refers to Claude, number 2 refers to Maud. So number 1 refers to Claude, number 2 refers to Maud. Okay, so we're going to write out the equation. So the mass of Claude times the initial velocity of Claude plus the mass of Maud times the initial velocity of Maud is equal to the mass of Claude plus the mass of Maud together, because they're stuck together, times their total final velocity. So we know really their masses. That's really pretty straightforward to plug in. We know their final velocity. We calculated that in part A. Or we really know this whole side is 960 from the kind of the problem statement. The only thing we have to think maybe a little bit about is the velocities. Oh, sorry, this should be initial velocity 2. So let's look at this initial velocity of Claude. So the initial velocity of Claude is going to be what? Let's look back at the problem. So the initial velocity of Claude is 0. So it said in the problem, Claude who is standing still. So the initial velocity of Claude is going to be 0 meters per second. And the initial velocity of Maud is what we're solving for. That's a question mark. We really don't know that. So again, we're going to plug in. We know that Claude has a mass of 65 kilograms. So we get 65 kilograms times, well, 0 really, because he's not moving, plus 55 times the initial velocity of Maud is equal to, this whole side, the whole right side is 960 Newton seconds. And we're going to solve that out to find the initial velocity of Maud is going to be, sorry, this should be a 2, is going to be 17.5 meters per second. Okay, so that's D. That's Maud's initial velocity. And E, what type of collision is this? Again, pretty straightforward. This is an inelastic. And the reasoning is the objects stick together. Okay, so that's all of problem number 2.